So today I'll be giving a brief technical explanation of an internal combustion engine. The real definition of an internal combustion engine is it's the fundamental process of releasing energy from a fuel and air mixture, which is called combustion or burning. And the process is a fuel ignition and combustion inside of an internal combustion engine, or also known as ICE. And it takes place inside of this engine here. And after that, the engine uses a portion of the energy produced by combustion and power itself um, to allow the stationary cylinder and a moving piston that make up the engine to allow the power to go into the powertrain on the backside of the engine. As you can see by this exploded diagram here, this is an exploded version of an engine, just showing a little bit of the parts and pieces of it there. Um, Next, we have a slide here that shows all of the main components, which this shows at the bottom. It shows the engine block itself. They're most of the time made out of aluminum or steel, rarely made out of um, iron or something of that nature, a different material. Basically, what that does is it's the main housing for the engine itself. Inside of that, you can see the crankshaft just a little farther up, and the crankshaft converts the reciprocating motion, which is an up and down motion of the piston, and it creates a rotating motion from that. The pistons, which are the cylindrical shaped objects right there in the center of the engine, as labeled on the diagram. The piston, or also known as the thorax, is the heart of the engine, and which that's a direct role in the combustion process. When it comes up, and comes near that spark plug, it's going to fire off and create combustion in there. Next, we move on to the camshaft, which the camshaft is located at the top of the engine, and along with the cylinder head, that's responsible for the opening and closing of the intake and exhaust valves. So the intake valve allows the fuel and the air to come in, and the exhaust valves allow for, after the combustion has happened, for it to then escape from the exhaust. So just like the exhaust pipe on a car. Um, Then we've got the spark plug. The spark plug is actually what has electricity running through it and sparks that fuel for it to ignite. The fuel injector, which is not pictured here, that sprays a specific amount of fuel into the cylinder wall. And what that does is when it sprays the fuel down in there, that spark plug sparks off when the piston rises, and it sparks off, creating that combustion, which creates then power, and it goes out through the drivetrain. The valves, which you can see a few there in the picture. That's what I was just talking about a second ago, and where they allow the intake valves allow that air and fuel to transfer inside to the cylinder wall and on top of the piston. And the exhaust valves then open up and they allow all those gases to escape and go out of the exhaust pipe. The connecting rods, which are what connect the crankshaft to the piston itself, that's what forces, when the crankshaft rotates, it forces the piston up and down, so it can make that linear motion up and down. The cylinder head there sits above on the top of the engine, and that allows that space creation and houses all the valves and things up top. Creates that space in between the piston and the valves themselves. And then on the front of the engine, there's a timing chain, which that can either be a metal chain or it can either be a reinforced rubber belt. That's pretty much what drives the crankshaft and the camshaft. So when the camshaft rotates, or excuse me, when the crankshaft rotates, it makes the camshafts rotate up top in a certain series that allows the exhaust valves and intake valves to then open and close in a series. The main use of internal combustion engines in the United States, more than 250 million highway transportation vehicles use them daily. Every time you get in a bus or a plane or a car or something of that nature, there's more than likely it's got an internal combustion engine in it. They're responsible for 99% of our transportation and delivery of goods and services in the U.S. Looking forward, the energy efficient alternatives. Most internal combustion engines run on gasoline or diesel, but there are things like natural gas, propane, biodiesel, and ethanol that can be put into these engines for them to run off of also. They do have to be um, made for these different fuels, but they can be ran on it, and they can be paired with plug-in hybrid vehicles. So a good example of that is a Toyota Prius. Yes, you go to the gas pump and fill it up, but at the same time, you can come home and plug it in, and you get double the fuel economy out of it, and it helps out a lot with the fuel efficiency. Also, another thing to do with energy efficiency is the particle filters on vehicles. As it states here in the next little paragraph, um, everything is measured, whether it be the performance, the acceleration, the 0 to 60, um, and all that's brought, through the manufacturers from the EPA when they do their um, regulations on emissions and their measurements on emissions. So as of now, the EPA has regulations on the ICE, the internal combustion engine, and they also have to have particle matter filters and the um, O2 sensors that are measuring the amount of nitrogen oxide that's coming out of those engines going through the exhaust pipe. So, um, over the past 30 years, things have drastically dropped when it comes to emissions, and that has actually assisted the manufacturers and boosted the fuel economy. So, it's coming out good in the long run for everyone. And that there about sums it up for my presentation of my internal combustion engine here. And here are my references. If there are any questions, comments, or concerns, please let me know. Thank you.